Hello everyone, welcome to Computer Vision and ML tutorial. Imagine an AI that doesn't just describe what it sees, but can point to exact spot in an image. Before this challenge was very difficult to overcome, but Cosmos 2, developed by Microsoft, is a multimodal large language model which solved this problem. Cosmos 2 ability to link word directly to image region through bounding boxes and special location tokens, treating them like invisible hyperlink that connect text and pixels. Before Cosmos 2, vision language models struggle with ambiguity, asking where is the cat might return a general caption, but never the precise region. Developer had to build separate object detector and then fuse their output with text model, leading to error in vision language tasks. In this tutorial, we are going to learn about Cosmos 2 through its research paper, and also I will show you how you can run it locally on your system. So let's review the research paper of Cosmos 2 called Cosmos 2 Grounding Multimodal Large Language Model to the World. So in this research paper, the author introduced Cosmos 2, which is a MLLM, which is stand for Multimodal Large Language Model. What does multimodal means? Means it can take images, audio, or vision language tasks, but Cosmos can only take language, image, or vision language. So it's a partial multimodal, not a full multimodal by today's standards. But it was introduced in 2023, so at that time it was considered a multimodal. So the expression it gives as a result is in Markdown, as you can see. So it links in Markdown, text span, and bounding boxes. This will be the text it is talking about, and this is the bounding boxes of the object it has detected in the image. So where object description are the sequence of location tokens. So this bounding box are of location tokens. So it is trained on grid. Grid is a data set. It was trained, which is used in vision language task. Means grid dataset contains vision with language pairs. We will talk about it in later of this section. So when Cosmos to detect its object, it give data in this form. That object is talking about, and then the location tokens. Here is the location token about the top left point of the bounding box and that lowest right point of the bounding box. So this provides us the location of the campfire it is talking about in this image, as you can see. So and similarly for the snowman, it can also understand a general understanding. Means it can, if I am talking about something, it will understand it. Here it is the snowman. Let's see some examples. Like if I give him the input prompt of the left eye of emoji, the completion will be the bounding box covering the left side of the emoji, which is a heart. And similarly, the if I input with a question, how many cows are here, the two cows present in the image and the bounding boxes around the cows have been made. So then another question will be, what does the sign say? And answered, the sign say welcome to Carnaby Street, and there Cosmos has marked the uh, letters which is talking about Carnaby Street. Then it can also understand some context reasoning, like why is this animal unusual? So it is given a detailed understanding, like turtles are slow and rabbits are fast, and it is unusual because turtle can't run in match with rabbit. So it's understand the context of a image in detail and then answer it. And also if you give it a question like what is it, so it here it understand this. So a buoyancy attached to the boat, here it represent this, so it understand the what object we are talking about. Or like for another question, what is the biggest difference between bottle 1 and bottle 2. So it has marked the bottle 1 and bottle 2, but there is a problem, which is bottle 1 and bottle 2 we are talking about. I don't know the how it is understand this is bottle 1 and bottle 2. It can be this bottle 1 and this bottle, but they are in half, so it understand like this bottle the person is talking about, so it understand the bottle, and also the difference between them is their labels. So it understands images quite well according to the research paper author. So if you input would be describe the image, it will provide us with the uh, description of the image and also with the object it is talking about. So here you can see the objects here talking about is marked in the color respective to the objects here in the picture. So let's see more about Cosmos 2. So in introduction, it is told about is the grounding capability can provide a more convenient and efficient. So grounding means here to connect the relationship between text and the object in the image. Like if I am talking about a snowman, so snowman should this text should has a relationship between this object in the image. So this is the grounding capability of the Cosmos 2. So Cosmos 2 is built upon Cosmos 1. As we know, Cosmos 2 is a transform-based causal language model. It is trained using next word prediction. Yes, if you are using an NP large language model, transformers is necessary. Then it's talk about its grid data set, which I talked about in the start. A large scale data set of grounded image text pair. So it in this data set consists of a pair between a with image and its description in a large volume, and on this pair the model is trained. So let's see, like this is the image and this is the description of the image, a dog in a field of flowers. So as you can see, it says and understand the dog, field and flower part, which are nouns, and understand the relation between flowers. So and it compose the bounding boxes for it also, key drop. So it understand this is the main point of this whole photo. So let's see. So in the end, we obtain approximately 91 million images, 115 million text spans, and 137 million associated bounding boxes. So let's go. So as you can see, this is the part it is talk about how the bounding boxes is represented. It's by boxes and locations, which we talked about. This is the format in which result is provided, and we it's a markdown format. Then about its training setup. Our training process involves a batch size of 419K tokens consisting of 185 tokens from text corpora, 215K tokens from original and grounded image caption pair, and 19K tokens from interleaved data. So it is saying equivalent to 25 billion tokens. So it's a large, very Adam W optimizer is used here, and 256 V100 GPUs, and training takes around 1 day to complete. So with this large volumes of GPU, it still took 1 day. So it very according to 2023, it will be a large model. So let's see. Uh, after model is trained, we perform instruct tuning to better align Cosmos with human. So it after training on the grid data, it also train on another data set of visual language instruction data set, Lava instruct and large language only instruction data set, and unnatural instruction plan to. So its data set is quite large. Let's see what it's more talking about. So this is the way grounded MLM. It's so a man in a blue hard hat and the orange vest, and it marked the orange vest Twitter link that provided the address to the address to the part of it is talking about. Then hmm, page counting. These are the capabilities. These are the result it has to store. So in validation test split, these are the things. Let's see what shows up here it is. So it can also understand the context of the image, like if I give it in the prompt like the frontmost cow to the right of the other cow, so understand which cow I'm talking about. Similarly here here it want the middle of giraffe in the middle, so it marked the giraffe in the middle. So it's the zero sort evaluation, it's few sort evaluation. So let's see another thing. So these are all the things the author claim Cosmos 2 has achieved. We will see it further in our implementation. So anything else? So So, well, let's see what grid data set it has. As you can see, this is the grid data sets of sample image of grid. So this is a plate in which food is presented. So grid data set, the image and the language has been in pair. So this object is related to this pair of text. Similarly, the aluminum tray, a small uh, bowl filled with creamy light green. So as you can see, these are the images from grid dataset on which the Cosmos 2 is trained. So it must be good on understanding the ground where the images are in the in the image we are searching, means where the objects are in the image. So this is also a few examples of great data set. So let's move to its implementation and see what the author claims are true or not. Now let's start by implementing Cosmos 2. To implement Cosmos 2, you have to install some libraries which are dot, transformers, pillow, and accelerate. So these are the libraries you will need to implement Cosmos 2. Let's install them. Now libraries has been installed. Then we import these libraries. Get to importing these libraries. As you can see, I am importing image from pillow request transformers. I am importing auto processor and Cosmos 2 for conditional generation, and these two. Let's import them now. I'm creating a helper function. This function is the sole purpose to visualize the image I'm taking as an example for this tutorial. So I have to just give it the source like URL and the part of the image I'm using, and it will display me, nothing else. So let's run this. Now the most important code, the checkpoint. I am using Microsoft KOSMOS-2 patch 14 2024. So this is the model I'm going to use. So I have to create two variables for this, a model and a processor. Using Cosmos 2 for conditional generation, I am creating this model variable and a processor for using auto processor. Now let's Now as you can see, the model is downloading. It's around 6.66 GB. It's a large model according to 2023, but now it's a very small model, you can say. As you can know, Pixel and other models are very large compared to this. So our model has been downloaded pretty much. Let's take a sample image. This is the sample image provided by Hugging Face Cosmos 2. So in this image, the model is trained very well. This is the image on which we seen in research paper. This is a snowman warming itself with a campfire. So let's to run this Cosmos 2, I have to give a prompt. As you know, in the research paper, I mentioned that grounding is used to uh, implement the grounding feature of Cosmos 2, in where you will get the address or a hyperlink to the yeah, object image, and then you have to follow this by a processor provides the prompt to detect an image, and then you have to perform this. Then these are generated tests and process text which are shown here. Let's run this. As you can see, the cleanup and extract for x is equals to false, like so the process data will have the all the tags of the object it has detected. So, you will see it now, but you can turn it to true to clean up and extract the information in separate manner, like here you can see. As you can see, when the cleanup and extract is false, the result is given in with all these tags. You can see the grounding is in the first, then the image of a snowman and the place and its location. This is the location detected by the object, detected of the object by the model, as you can see, and it's giving us a general description of the image. Warming a snowman warming himself by there's another object called fire, then fire, and then this. So in simple, it's saying, and it is very difficult to read, so you should use true and take the take the other variables of location in this format, which make it easier to use it further. So the model is saying an image of a snowman warming himself by a fire, and the location of a snowman is here. As you can see, this is the box of the fire snowman, and the and of the bounding box of the fire. You can see. Now let's create this function, this whole script in a function. So this is a function you should create, which where arguments should be an image, a prompt, and clean up and extract if you want true. Like if you want result in that format, you can use true. If you want a result in that, you can use false. So let's run this. Hmm. Let's take this image again. Hmm. So let's run this question which I have run previously, an image of. It is giving me a same as that. So now let's ask question related to the image, like what will happen to this snowman. It's a question in which if a model has a context to the image and its understanding, then it will give us a proper answer. So what will happen to the snowman? Snowman will melt away in the heat of fire. So it understands what a snowman is, and snowman will melt in heat of fire. As you know, I am not providing it with grounding, so the other result is like this. So this box is at empty. If I provide with as you can see, grounding, let's do the same here. Grounding, let's see. As you can see, the snowman object is detected, but it is not detected a fire object, which I don't know why, because if the sentence has both snowman, both objects should be have been present here. So this is the fault of Cosmos 2 model. Let's get to another prompt. What is happening in this image? Let's get a general description. So it's giving us a more detailed description of the image. The image features a snowman wearing a hat sitting in front of fire. The snowman is surrounded by snow. The fire is burning brightly. The scene is set in snowy forest with the snowman and the fireplace providing warmth and comfort. So it's understand the image and provided a general detailed description of the image. So I have created this script, as running this code line by line is too much tended uh, hard task and time consuming. So we will just ask a set of question in a list and run this. So what my first question is, what is the color of the snowman? Second is provide grounding. What is the color of the snowman's hat? And I need the location of the snowman hat. What is snowman doing in the image? Is something bad's going to happen in this image? It's a context space. If the model understand, it will understand that snowman will melt in the heat of fire in the heat created by fire. What will happen to the snowman? What will happen if snowman melts? Let's see. Our first, what is the color of snowman? The color of snowman is white. It's true. Then what is the color of snowman? And the snowman cap is blue. Let's see, it's around blue or gray. Then it's giving me the snowman caps location. So this is the it's true. Now what is doing? The snowman sitting by the fire in this one is true. Is something bad going to happen in the image? Yes, but it's not provided what will happen. So it's limitation. What will happen to snowman? What will happen? Snowman will melt away in the heat of fire. So it's understanding what will happen to snowman. It's performing quite well. But this image is the data set on which belongs to a data set on which the model is set, so it has a great understanding of that image. So what will happen in snowman melt? Yes, yes. With what will happen? You are seeing that it's hallucinating. If a snowman melt, it will cause a lot of damage to environment. Snowmen are known for their ability to melt snow, which is why, as you can see, the model is hallucinating right now. When the question becomes too complex, like what will happen if snowman melt, it's a very complex question according to this model. So it starts hallucinating and giving us random gibberish. As you can see, it led to flooding, erosion, and other environmental issues. I don't know why this model is providing such useless information. Now let's take a image which is outside from this data set, training data set. So as you can see, this is the image of a two elephant holding their trunks. So let's ask them question. Question one is an image of I want description. Which animal are in this image and what are the elephants doing in this image? These are pretty standard questions. Let's see what happens. Mhm. Mhm. So as you can see, the model is providing us wrong information. Two lions. There are no lions in this image, as you can see. So it is wrong. It's saying a image of two lions standing next to each other in a zoo enclosure. Zoo enclosure part is true, but the animal it has detected is for false. Which animals are in this image? In this image, there are two animals. What's the sense? Two animal. You have to give me under description. There are two elephants. I have also provided the question. What are the elephants doing? In the image, two elephants are standing close to the possibility in a zoo closure. They are both facing same direction. Their same direction is wrong. They are facing each other. With one elephant slightly to the left, it's not providing us accurate information about the image. Let's take another image. So this is an image of a telephone booth in front of Big Ben. It's a pretty standard image. There are not much things going on other than a person is standing here. Let's see. I want a general description of this image. Where is this image taken? The location. So it will be London, in London, UK. What is the tallest object in this image? So Big Ben will be the tallest. And then any person in the image. I am talking about this person. Then where is the person in the image? I want the location. So let's see what will happen. Hmm. So an image of tall building and a clock tower in London, England. It has already provided me the location of the image. So it's showing so tall building. So where is the tall building it is talking about? And the Big Ben and clock tower is the Big Ben here. So it's working right here. Then where is the image like in London, England? So it's true. Tallest object in the tallest clock tower. It's talking about Big Ben, but it's right clock tower. Any person is yes. The person in the image is a cityscape with a blue sky, a building, a building with a clock tower. As the model is hallucinating here, it's creating random gibberish sentences. This image, the object is wrong there, so the location will also be wrong. So this model is not understanding where is the person. Mean it has not detected the person yet. Let's take another and our final sample image. So this is a funny image of a boy which face is smashed in cake. Let's run these two questions. An image of where is the wristwatch. So this is the wristwatch I'm talking about. Let's run the model. So an image of a man smashing a cake with a sledgehammer on his head. I don't understand where it's saying a sledgehammer. I think the model understanding this hand is a sledgehammer, so it's wrong here. A man and a sledgehammer. Where is the wristwatch? Wristwatch is located in the middle of the table. The description is quite wrong here, but location providing is of the middle of the table. It's around this part, so it must be this wristwatch, but it's not providing us with the right description. So this is all from me today. Now you understand how you can implement Cosmos 2. So experiment it yourself and see the result.
For more computer vision or machine learning related tasks, you can check our GitHub, where you will find everything in one place.